EdgeSec TEE leverages trusted execution environments to enable secure handling of sensitive data and execution of code segments that require strict confidentiality. To utilize EdgeSec TEE, a container compatible with contemporary Intel processors is required as it relies on the underlying Intel SGX technology. Intel SGX is a set of security-related instruction codes that enable application developers to create enclaves that are isolated regions of code and data, protecting sensitive computations from the rest of the system. EdgeSec TEE is based on the SCOAN confidential computing technology that leverages Intel SGX to provide secure and confidential execution environments for applications. SCOAN extends the capabilities of Intel SGX by providing an abstraction layer for easier enclave development. Applications are packaged as secure containers, allowing easy deployment and management of secure workloads. EdgeSec TEE follows the scanification process to generate a confidential image. The Scanify image tool enables the transformation of a native container image into an encrypted SCOAN-enabled image in a single step. This transformation, known as scanification, allows the scanified binary to execute its service within an SGX enclave using the SCOAN runtime. Native image files are encrypted and their integrity protection is ensured. Access to them is provided only after attestation by the SCOAN platform. A SCOAN policy is generated, incorporating native image environment variables and the working directory. To integrate EdgeSec TEE with the Marvel framework, we paired it with another Marvel asset, the Video Anani. Video Anani operates with sensitive data such as usernames and passwords of RTSB streams. To secure this data, we removed it from Video Anani and added it to a Flask application that is running within an SGX enclave. Following the SCOAN workflow, we initially implement the Flask application with the sensitive data of video streams to act as our native container. After the scanification process, we deploy the encrypted container within the Marvel framework. Upon running the encrypted container, the process of remote attestation with a remote CAS occurs. After the successful remote attestation with the remote CAS, the Flask application is ready to serve the sensitive data. To verify that the Flask application is transformed into a confidential service, we attach to the running container gaining access to the contents of the container. When we try to see the contents of the scanified version of the Flask app, the contents of the code are encrypted.